I think last class I mentioned about assignment 6, we put assignment 6. And on that same day, what I did was this is assignment number 6. On the same day, I put also posted frame element. So we'll talk about a little bit about frame element once we are done with beam element. But this is just similar to our bar and truss element. Okay, by the way, there's also the lecture video by Dr. Nick. You can just, again, I think what you want to do is to have to watch and to do the assignment together. Okay, assignment 7, because assignment 7 is based on Dr. Nick's lecture. All right, so just like I mentioned last time, we are 2 weeks behind. We are 2 weeks behind, so we need to catch up. And I think I also mentioned about a group, a group of 3 for your project. And I hope every one of you has downloaded this thing. Since you are at home, I hope everyone has a good connection. Kalau tak, pergilah mana-mana, pergi Starbucks ke, pergi McDonald's ke, download dah sekejap. Okay, and these are the some of the examples. Again, for your information, this is my video, NC's beam demo, frame problem demo. This is based on our assignment. These 2 are based on our assignment and how I solve it using NC. And once again, I'm no expert in ANSYS because I'm just learning since last semester. I'm just learning how to use ANSYS. So you might find a better way somewhere on maybe YouTube or whatever, but I think it's good enough for our class. Okay, it's good enough for our class. But you need, if you want to go learn more, maybe you do not depend on my video, because saya ni pun newbie je sebenarnya. I'm still a newbie. So it's good for me to actually can show example to solve the class example problem. Okay, so this week should be this one. This week should be this one. But once again, I have posted the lecture slides, and I also posted the video by Dr. Nick again. So I guess after this is all videos by Dr. Nick. I think Dr. Nick. I think if I have my own video, I think this Dr. Nick's video is much better lah. Much better. That's why I use Dr. Nick's video. So CST, what is CST? Let's talk about CST dulu. Actually, I want to talk about beam element again, but never mind. We can put that on hold for a while. But remember that our class flow. Remember our class flow. Okay, so we start with bar element. Which is our bar element is 1D. 1D, 1 degrees of freedom per node. 1D element with 1 degrees of freedom per node. So we have node 1 has 1 degrees of freedom, which is Q1. Node 2 has 1 degrees of freedom, which is Q2. Overall, it has 2 degrees of freedom per element. So after that, what we did was we put the bar element on an inclined surface, for example. So we put it at an angle. So what we get is that we get the truss element. And still, truss element is again still a 1D, 1 dimensional element with 2 degrees of freedom per node. Okay, per node. Right, so that's the progression. I think bar element was tested in our test 1, and I was marking test 1. Sedih lah saya tengok sebenarnya, sorry lah. I think dalam soalan mention specifically use 2 elements kan. Ada ramai yang guna 3 elements. Sebab apa? There's 2 points of interest there. One is P, the other one is alpha. Okay, the other one is alpha. So you use 3 elements, which is not what the question asks. The question asks for 2 elements. Okay, so please read the question carefully. Please read the question carefully. I think you were given 5 minutes extra before the test starts. So which means the password will reach 5 minutes before you can start. So you can read the question and understand the question. So this is where a lot of students is making mistakes. So by the way, I've done only 1/3 of the papers because I'm the one who marked the question one. Question one. All right, so that's the progression. And then after that, we went to bar element. And I think I showed you last time that bar element is looks like this. We have V and we have prime. So one is what we call vertical displacement or what we call transverse displacement rotation. And this is V1. This is V1 prime. This is V2. And this is V2 prime. So what we did was we mapped it to Q1, Q2.
Assalamualaikum doktor. Doktor tak nampak apa doktor tulis.
Sorry. I didn't share that one yet. Okay. Thank you. Yang lain semua tidur ke apa? Senyap aja. Sekejap ya. Let me share.
And mic doktor dia macam ada bunyi.
Tu mic saya tengah tidur. Dia bengkok.
Macam tu pula.
Okay, so let's see this one. Like I told you just now, I have PC problem and mic problem. So I don't want to restart my PC again. So it will take a long time. So can you see my paper now? Okay, so let's rewind a little bit. So what we did the first time that we were introduced to the class, what we did was we have this bar element, where bar element is a 1D element with 1 degrees of freedom per node. So in this case, node 1 has Q1, node 2 has Q2. So basically, 1 degrees of freedom per node or 2 degrees of freedom per element for bar element. So, and then after that, we tilted or we put the bar element at an angle. So now, this is what we call the thrust element. And you can see that for thrust element, it is still 1D, but 2 degrees of freedom per node, because we have the horizontal and the vertical displacement. So that's how we progress. Now, what we did is bar element, which has 2 degrees of freedom. It is still 1D element with 2 DOF per node. 2 degrees of freedom per node. And what are the degrees of freedom? Which is our transverse displacement, V1, and our rotation at node number 1, which is V1 prime. And then the same thing for our node number 2, we have V2, and then V2 prime. And what we did was we mapped it, I think in one of the questions, we mapped it to this one. Okay, in the question, so we mapped it. V1 is Q1, V1 prime is just Q2, and Q3, and of course, this one is buat hal lagi. For some reason, I cannot write. I cannot write on my tablet. Alright, so hopefully after a while, okay, kat sini boleh. Kat sini, okay, never mind. So let's close this one. And okay, and Q1, Q2, and Q4. So this is still 1 degrees of freedom. One dimensional element with 2 degrees of freedom. Okay, so this is the progression where we are right now. But if you look at your planning in your e-learning, after that, what we have to do is a frame element. So what is a frame element then? A frame element is just like trust element. Okay, just like a trust element, but now it is at an angle. It is at an angle. So for this case, a frame element, you have, it is still one-dimensional, but 3 degrees of freedom per node. Okay, so this is the frame element. So just like a truss element, we need to do some transformation. We need to do some transformation. So this is the idea behind frame element. It's just a beam element at an angle plus some truss element. So it's a combination of beam plus truss element. So that's why the 2 degrees of freedom will come from the beam and 1 degree of freedom will come from the truss. So it's a 3 degrees of freedom. So I hope you can see that the process is the same, except that the level of difficulty is getting harder and harder. That is why, if you feel test 1 is hard, you need to study hard. You need to not study hard. You need to study harder. Okay? You need to study harder, not hard. Hard is not good enough. Study harder. Okay? Now, this is our frame element. So I think once you watch the video, hopefully you can see the difference between beam and frame element. Now the next thing is this one, which is our CST element. So what is CST? What is CST? CST stands for constant strain triangle. Okay, so CST element is A is the element will shape is a triangle. So this is a triangle. So this is the element. Now, hopefully you can see that this is a 2-dimensional element with 2 DOF per node. Okay. So this is how we do it. This is how we do it. So it started with 1 degree, 1-dimensional, 1 degrees of freedom, and then we fill it, we put it at an angle. Then we have 1-dimensional, 2 degrees of freedom, and then we go back to, because the first two, the bar and plus element is just basically displacement, but for beam we need some bending. How do we model bending in our finite element? So for beam element, it is 1D element with 2 degrees of freedom, which is the transverse displacement. Transverse displacement. Where is it? Here. Transverse displacement and rotation. And then we put it at an angle. Then it becomes frame. This is basically, we can see that it is beam plus. Oh, maybe, sorry. I think beam plus bar or plus. Okay, so that's frame. And the next level is CST. So this is the progression. This is the progression of our, and of course, element, a 3D element, which can be a cube. And how many nodes that we have for a cube? We have 1, 2, 3, 4, 5, 6, 7, 8 nodes. Okay, 8 nodes. Okay, and this is what we call, all these are our structural element, basically solid mechanics element. And of course, we also have the heat transfer element, which is after our CST. Let's see if I have this one. Okay, heat transfer, 1D heat transfer in things. Actually, here, this is another element for heat transfer. Okay, should be here. It should be here, or maybe should be here. Okay, so I haven't updated the e-learning yet, e-learning portal. So I hope you can see. I hope you see. The thing is still the same. You need to find the K matrix. You need to find the element stiffness matrix. You need to find the element force vector. You need to assemble to make it global for the stiffness matrix. And of course, the force vector. Apply the boundary condition and then solve for the unknowns BOF, unknown BOF. This is the first question in your test one. Test one. Itu saja. So the approach is the same, but level of difficulty become harder and harder as we progresses. Okay, as we progress. So this is the idea. This is the idea. Okay. So far, any question? Is my mic better now or still bunyi-bunyi lagi? Anyone?
Bunyi sikit, doktor.
Tapi boleh faham You can still understand me. Okay, that's fine lah. That's fine because maybe nanti boleh beli mic baru kot. Okay. So alright. So let's go for. Okay. So what I want to do today is to go back to our assignments. To go back to our assignment, and I don't know where you have where you are with respect to the assignment. I was hoping at least we have done half of it because it will be due on next Sunday. Next Sunday. So let's open up the assignment. Assignment 6. Okay, so let's see the parallelism. The parallelism between our bar element and our beam element. Remember our bar element is just a 1D, 1 degrees of freedom per node. But for our beam element, it is not. It is not. So dalam case kita, I think we started with, for bar element, we started with displacement. Kita punya displacement or U. We know that U is just TL over AE. Okay, this is the theoretical displacement. But for our beam, there are two deformations that we need to find. One is V, and the other one is this V prime. So this is what we want to do. And this is just the relation. This is from solid mechanics. This is not from finite element. This is from the solid mechanics. And what we have here, this is the relationship between the moment and our curvature. Note that this is V. We know what is V. We can find V, and we can also find dx. This is what we call the transverse displacement. Okay, this one is the rotation, beam rotation. These two are the physical deformations that we can find. So again, okay, so dalam case bar tadi, what we have is only U, which is TL over AE. But beam, we have two quantities that we can find. Okay, and note that for beam, for bar, we have for bar element, we have Q1 and Q2. So remember, the problem was, okay, this is at node 1 and node 2. The problem was, what if we want to find at this location, what is the displacement there? What is the displacement? Okay, so this is where you use your shape function. And again, this question about shape function dalam soalan test 1 is the last question. It's the last question. The displacement at location alpha, right? Okay, so how do we do this? So we have to use shape function where we use n1 q1 plus n2 q2, right? So this is for bar element, and of course n1 is a certain function 1 minus z over 2, and N2 is 1 plus Z over 2, and I don't think I need to go back into that discussion, because by now I think you should have mastered this. Okay, and the same thing with beam element. We have Q1, which is the transverse element. We have Q2, we have Q3, and we have Q4. And the question is, what is the transfer displacement at this location and the rotation at this location? So we need a shape function, right? We need a shape function. Okay, but this time it is not linear. This is not a linear shape function anymore. Why? Because we have 4 known values. We know Q1, we know Q2, we know Q3, and we know Q4. So this is what we call, okay, I think by now you know that our shape function is basically just an interpolation function, right? It's just an interpolation function. So in this case, it is straightforward. In this case, for bar element, we know what is Q1 and what is Q2. So we know 2 quantities. So in this case, the shape function should be something that A naught plus A1 Z. And this is a linear function. This is a linear function. And we know that N1 is just 1 minus Z over 2. Okay. The same thing. So basically our A naught is half. Our A1 is also half. Okay. So that's the shape function. But in this case, if you take a look at this, we have four known values, which means the function should look something like this. Okay, A naught. Okay, I think the one that we used was not A naught, but we used A plus B plus C Z square plus B Z cube. Okay, so now it's a polynomial of the 3rd order, because we know 4 values. Okay, the highest order that we can construct is a 3rd order polynomial. So the question is, what is A, what is B, what is C, and what is D? And note that H is a function of the location in the natural coordinate system, which is Z. Okay, so now this is what I want to tell you, because part of the question is this. Okay, so this is the question, and it says okay, show this. So this one is very straightforward. And prove that for H1, A1 is half, B1 is 3 minus 3 over 4, C1 is 0, D1 is quarter, 1 over 4. So how do we do this? Note how many unknowns do we have there? You have A, B, C, and D. Okay, we have, in this case, we have 1, 2, 3, 4. So we have 4 unknowns, which means we must have 4 equations. Okay, 4 unknowns, and we must have 4 equations to find what is A, what is B, what is C, and what is D. And what is D. So fortunately, I think in your textbook, it's only given. So this is for H1. Note that there are 4 conditions here. There are 4 boundary conditions. For example, if you look at slope at node 1 or at z equal to minus 1, the slope is 0 and the displacement is 1. So we know that H something's wrong. Never mind. So we know these are 4 conditions. We know that H at E, H as minus 1, okay, the value is 1. H prime, okay, is 1, H1. H prime at -1 must equal to 0. H1 at 1 must equal to 0, and H prime 1 at V equal to 1 must equal to 0. Okay, so there are 4 equations with 4 unknowns. So can we solve for what is A, B, C, and D? So that's the idea. So you have to do this for every H. H1, H2, H3, and H4. Okay, so let's try to do this. Hopefully, I did not make any mistakes. Okay. All right. So this is our case. So the question here is this one. It says proof. I think this is the one. It says here that start again. Okay. Proof that for H1, A1 is half, B1 is 3/4, minus 3/4, C1 is 0, and B1 is 1/4. So this is what I want you to do basically. So let's look at, okay, let's, I don't know what happened. I think Windows keep updating the OS. Sampai saya punya laptop ni dah macam-macam hal lah. Okay, let's look at the question again. Assignment 6. This is tiring. Okay, so this is the one. This is the one. So this is the one. Okay, so this is what I'm trying to show you. This is what I'm trying to show you. All right, so of course, once you can do for number 2, you can repeat for H2, H3, and H4. So that is the one lah. I think this part is simple. This is just if you know what is the it's not allowing me to write something here. I think I need to change software. Software ni dah tak berapa bagus lah. Asyik crash ni. Okay, so you know what is dv. You know what is dv dt, and of course you can do dv dt square. So, oh sorry. Note that our v, note that our v is in the function of v. Okay, so dv dx. Okay, in this case dv dx. It wants dv dx. Okay, so what we can do is dv dx. But before that, what is dv dx? Dv dx is just dv because note that in our case v is a function of v. Let's write this properly so you can understand the math here. Okay. So we know that our v is a function of v. So what we can do is we want to differentiate our v with respect to x, and note that x is our global coordinate system, and our v is just our local coordinate or natural coordinate system. So we want to differentiate this. Okay, with respect to x. So this is just dv dv times dv times dx. So do we know what is v as a function of x? Okay, we know what v is we know v as function of z, but do we know what is v as function of x? Remember from our bar element? Remember from our bar element? Okay, I hope you still remember from our bar element, because v equal to, if I'm not mistaken, 2 over L, something, right? X over x1 over x2 or minus x1, which is just me, minus minus 1, if I'm not mistaken. Please double check my, I think my memory is not that good anymore. Okay, so now you can do that. Okay, so now the question is, how do we solve this? Because once you can do this, you can do for H2, H3, and H4. Okay, we look at question number 4. Why do we need v square, dv square, dx square? Because note that our n is equal to ei over L times d square v dx square, which is okay. This one is okay. So I think there's a because there's an L here, so it will cancel out. Because this is the relationship between moment and uh, transverse displacement v. Okay, so that is why we need this. We need this because we need to find what is our m. Okay, so how do we do this? So how do we solve this one here? Question number 2 here. How do we solve it? Remember that the requirement is that this one, this is the requirement. So let's do this. I don't have my solution with me, so I might make a mistake somewhere along the line. So please watch me. If I make a mistake, please let me know because for some reason I don't know why I keep my solution. Uh, okay, so we've done this. So this is for H1. So let's put on the new page here. Okay, so this is our CSP. Let's go this way. So H1 is equal to A1 plus B1 Z plus C1 V square plus B1 plus B1 Z cube. Okay, and the question is, what is A1? What is B1? What is C1? And what is B1? Okay, and we know our boundary condition. We say use boundary conditions. So 4 unknowns with 4 boundary conditions. So this is our H1. So this is our H1. So this is 1, 2, okay, note that this is our minus Z. This is our plus Z, and this is our 0. Okay, so we know that our H1 at minus 1, at Z equal to minus 1, is equal to A1 plus B1. B is minus 1 plus C1. B is 1 because the square, minus 1 square is just a 1 plus B1. And sorry, not plus. Okay, so it's a minus 1 because numbers of power. So this must equal to 1, right? Equal to 1. And okay, so let's do this. H 1 prime, uh, uh, which is just dh1 over dz with respect to z equal to d1 plus 2c1 z plus 3 d1 b square. So H1 prime at b minus 1 is just equal to b plus 2 C1 minus 1 plus 3b1 times 1, and this should equal to 0, right? Okay, now let's look at this one, H2 prime, sorry, not H2 prime, H1, H1 at plus 1 here. V is plus 1 over here. So 1 plus B1 plus C1 plus B1 must equal to 0. And H prime 1 at B equal to plus 1 should be B1 plus 2C1 plus 3B1 times 1 equal to 0. Now, let's put this in a matrix form so you can easily solve this. Note that this is just 1 is 1 minus 1, 1 minus 1. And this should be A1, B1, C1, and B1. And this should equal to 0. Oh, sorry, not 0, 1. It's 1. And then this is 0, 1 minus 2, minus 2 plus 3. And this should equal to 0. And the next one is 1, 1, 1, 1 equal to 0. And the last one is 0, 1, 1, oh, not 1, 2, 2, 3, and should equal to 0. Can someone solve this for me quickly using your calculator? Once again, I'm sorry because I didn't have my solution with me. So I might make a mistake somewhere. So please double check. Someone with calculator, can you please calculate the value? So what is A1? Wah, leceh ni nak pakai calculator ni. Please someone. Is anybody doing it? Senyap macam ni. Okay, let me do this lah. Pelan-pelan just bear with me for a few minutes. Tak ada orang nak buat untuk saya. Oh. Okay, hopefully I should get it right. Okay. I don't know if you can see this. Boleh nampak tak? Okay, saya guna reduce row echelon form ataupun Gauss-Jordan elimination. So from Gauss-Jordan elimination, what I get here is A1 equal to half, B1 equal to minus 3 over 4, and C1 equal to 0, and D1 equal to 1 fourth. Okay, so inilah jawapan saya. Jawapan saya lah. Okay, hopefully you can see kita tengok screen saya besar sikit lah. Right. Okay, so that's how I did this one. So hopefully it's the same value that we get. Okay, half minus 3 quarter, 0 and 1 fourth. Okay, sama. So if you can do for H1, you can do the same thing for H2, H3, and H4. Okay, so now our H1 become this. Just plug in all the values. I think C1 is 0, so that's why there's no Z square here. There's no Z square here. And this is how we get it. This is how we get it. So I'm showing you how to get that one. Okay, so the rest, H2, H3, and H4, I think you can do it on your own. Right? So ada sikit lagi yang complicated di sini. If you look at this, can you see the K matrix? Okay, we use this potential energy. Remember our bar element. Remember our bar element and our touch element. How do we find the K stiffness matrix for element? Element matrix. Element stiffness matrix. So we use energy then. We use potential energy. So this is the same thing here. This is the same thing. Note that we have to integrate from -1 to 1. Basically, this is the limit. Where the limit, remember for our element, the limit, the lowest is -1 E and plus 1 V. And this is why the limit is from -1 to +1. And you integrate this, you should get this graph. Of course, remember that this one here is EI over L cube here. EI over L cube, and plus 8 is missing. So this is just algebra. Note, this is a very tedious process. But once you can do it, then which means you understand all the steps. All the steps. You understand all the steps. You understand all the steps. Okay, can you imagine? This is a 4. This is a 4 by 4, right? This is a 4 by 4, which means we have our beam element. We have Q1, Q2, Q3, and Q4. Okay, so we have 4 degrees of freedom per element. But for frame element, the key matrix will be a 6 by 6, which means it has 3 degrees of freedom per node. I think I mentioned that. Here. Okay, so frame, one dimensional element with 3 degrees of freedom per node. So note that it's a combination of beam and bar element. 1 degrees of freedom will come from the bar. While for truss element, not for truss element, for frame element, what we have here, okay, note that it is tilted at an angle. So note that when you have a inclined angle, means that there's a transformation matrix involved. Remember, for our truss element, we have Lm 0, 0, 0, 0, Lm, right? For frame element, we also have our transformation matrix, which is, if I'm not mistaken, is, lama, saya dah lupa lah. If I'm not mistaken, Note that in our case, for our frame element, it's a 6x6 matrix. So what we have here, if I'm not mistaken, I cannot recall. And then we have 0, 0, 0, 0, 0, 1. This is just for the first node, the first node. Because the first node, we have 3 degrees of freedom. So that is why we have the, oh, this is not right. This is not right. I'm sorry. I think it should be cosine and sine, not this one. So what we have here, it should be a 6x6 matrix. So 2 is for the beam. 1 here is for the 1 here for the bar. For the so for the frame, let me show you what I meant here. For the frame is that we have this additional. We have this additional, and of course we have our rotation, and we have our this one here. So that's why we have 3 degrees of freedom. 3 degrees of freedom. So I think I talk more about frame later when we get into it. But just note, the approach is the same from your bar element. The approach is still the same, but note that the level of difficulty become harder and harder. So this is my recommendation. Please make sure you really understand your bar element. And that is one of the reasons why we have the question in test 1. And if you notice that there's no numbers, everything must be solved in terms of A, of A naught, L, and E. Why? Because I know you can student ni they are more like human calculator, which is what we do not want. What we want is that you must be able to think, and that is one of the reasons there's no numbers involved. Everything in terms of variables. In terms of variables. Okay, so this is the element. This is the frame element. All right, so now we are done with the element stiffness matrix. Element stiffness matrix. Then we can go to the force vector. Force vector for distributed load. Note that for beam, we have this kind of loading. We have distributed load, we have point load, and we have point moment. There are 3 types of loadings here. Note that because distributed load is happening on R on this certain line, which means it will involve the elements. So that is why we need to find this thing here. Okay, what we call the force vector for distributed load. Okay, at an element, at one element. But for point load and point moment, it is applied at our global level once we assemble the matrix. Okay, once we assemble the matrix, because point only involve the node point, the node point. But if you have distributed load along a line, which means it will involve an element or elements. Okay, so please take note of that. Take note of that. Okay. Okay, so this is the model, minor element model for this distributed load. For distributed load. Okay, so finally we are done. We know what is the moment, we know what is the shear force, and then you apply everything that you have derived to this. And I think this is a good exercise for you to do it manually and to compare this with NFIT. To compare this with NFIT. I think my video is talking about this. My video, I think my video, this video here, if I'm not mistaken, beam demo here, this one is based on this question. Okay, it's based on this question. Okay, so I think I'm going to stop here. Okay, I lost my voice because I have PC problem. I have night problem. A lot of things today this morning. Okay, so I think I'm going to stop here. You have 1 hour extra, yeah, which you can use. Which you can use to continue your assignment number 6. Assignment number 6. So I've given you all the clues. Okay, hopefully you can continue whatever I told you just now. Okay, so hopefully I'll finish marking by this week, and then you can decide either you want to drop my class or you want to continue with the class. But please note that you must also assemble a group, assemble a group of 3 students. So take note, I hope those students, please, if you feel that you are not doing well in the test, please drop, jangan nanti dah separuh jalan tiba-tiba ada orang nak drop. Ya, tinggal 2 orang di satu group, which is troublesome to the rest of the team members. Alright, so that's it. Unless you have any questions. Do you have any questions? Okay, if there's no question, I think I'm going to stop here. But please use this extra time to do your assignment number 6. To do your assignment number 6. So now it's already 4 p.m. It's 4 p.m. You still have about 40 minutes or 50 minutes to do your assignment. Okay, if there's no question, I think that's it for now. Thank you very much.